In this demonstration, I'll show you how to find the derivatives of hyperbolic functions. Functions that contain certain combinations of e to the power of x and e to the power of negative x are called hyperbolic functions, and the definitions of each are shown below. In this demonstration, I'll show you two examples on how to derive such functions. Let's start with question number 1. In question number 1, they are asking us to find the derivative of secant h 9x to the power of 4 plus 7. So what we'll do is look at our derivatives, and secant hx is equal to negative secant hx times tangent h of x. So let's use that. The derivative of this is equal to negative secant h of 9x to the power of 4 plus 7 times tangent h of 9x to the power of 4 plus 7. And we don't stop there. We will find the derivative of this, and we're going to use the power rule. We're going to bring this 4 down, multiply it by 9, and then subtract this by 1, which gives us 36x to the power of 3, and the derivative of 7 goes to 0. So we can rewrite this, and let's set this to y. Y prime is equal to 36x to the power of 3 negative secant h 9x to the power of 4 plus 7 times tangent h of 9x to the power of 4 plus 7, and there it is. Let's continue to question 2. In question 2, we have a term that is a product of two separate terms. Let's call this f and let's call this g. Now remember, since this is a product, we will use the product rule. And the product rule tells us this: find the derivative of f and multiply it by the function g, and then find the derivative of g and multiply it to the function f. Given that this is f, and given what we know about how to derive logarithms, we'll use this. And what this tells us is the following. So by following this pattern, we can start off by writing 1 over x ln of this number 6, and then the derivative of x is 1, so we'll just leave it like that. And we will leave g the way it is, cosine h of x to the power of 2, plus the derivative of cosine h of x to the power of 2. And we can look at our chart here. Our chart tells us that the answer is sine h of x, sine h of x to the power of 2, and don't forget to find the derivative of that and multiply it to this, which is 2x, and then you leave log base of 6 the way it is. Let's see if we can clean this up a little bit. Let's set this to y. So y prime is equal to cosine h x to the power of 2 over x times ln 6 plus this, which is the same thing. So there you have it. Two examples on how to find the derivative of hyperbolic functions. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.